This section is all about vectors. Vectors in 3 dimensions. The first thing to know is that a vector looks like an arrow. It has a beginning, it has an end, it goes in some direction, and it has some length. The next thing to know is that it's considered the same vector even when you move it around. So if I move it around, but if I keep the length and the direction the same, then technically that's the same vector. So I'm going to put this down. I'm going to try and move this vector over so that it starts at the origin instead of starting where it's starting right now. Actually, let's first stop and predict. So I'm going to move this back to where it was a little bit ago. So it used to have a starting point of 2, 1, 1. And it used to have an ending point of 3, 3, 4. So if you think, all right, if I start at 2, 2, 1, 2, 1, 1, if I'm going to move that over, so instead of starting here, it's going to start at 0, 0, 0. Where is it going to go? Well, this one goes from 2, 1, 1. Let's put it back to 2, 1, 1. Okay. This one starts at 2, 1, 1, and in the x direction, it goes one more in the x direction. So it's to end up at 3, 3, 4. And in the y direction, that's this one, the green one, it's going 2 to the right to end up at this point. And in the z direction, it is going up from 1 up to 4, so it's going to end up 3 higher than it started. So that should tell me about what's going to happen when I trade it around and move this so that it starts at the origin. It should go right 1, up, it should go x direction 1, y direction 2, z direction 3. That should be what happens. That should be the ending point when I move it. Let's see if it's going to cooperate. Can I move it to the origin? Yes. It took me much Googling to figure out how to move these points, by the way. All right, here we are. I have moved it around again so that x goes this way and y goes that way. And sure enough, it starts from the origin and ends up at 1, 2, 3. All right, time for some notation. So that vector, and the vector, remember, can be in a different place and still be the same vector. So it can start at 0, 0, 0. We'll start with the one I ended with, and at 1, 2, 3. Or we can say it started at, I think it was 1, 1 something. Oh my gosh. Okay, so first of all, I want to point out that you can get this 1, 2, 3 out of the 2, 1, 1 and the 3, 3, 4 by subtracting. So let's see if I can draw decently. So if I subtract 3 minus 2, and this 3 minus 1, and this 4 minus 1, that's going to give you the numbers that happen when you're going from the origin. 1, 2, 3. And to a certain extent, this is most like the standard name for the vector. Now, when we write something and we say it's a vector, then we are going to use one of two notations. So one is we're going to use these less than, greater than brackets. And those are going to be our vector brackets. And so this 1, 2, 3 means a vector that moves right, x direction plus 1, y direction plus 2, z direction plus 3. None of this left-right business. X, y, and z. Okay, so that is a vector name. When I use a variable for that vector name, so I might call that x or y or u or v, we use u and v a lot. When we name it a vector, we put this little arrow over the top. That means vector. There is another notation for this, and the notation is 1i, where this is a particular I that means the vector in the x direction, plus 2j, where j is a vector going 1 unit in the y direction, plus 3k, where k is a unit vector going 1 unit in the z direction. So those are our two notations.